So this is totally different to the open oceans. Okay, in the open ocean, you only need to measure temperature and salinity and other properties once, and then there will be no changes. So if you come back in a week or even a year later or 10 years later and you do the measurement, the changes will be very small in most instances. Okay, now in shelf seas it's different. You do a measurement in 1 month. Say you go with your grandma, you pedal along, do measurements here just in the Adelaide metropolitan area, and you come back 1 month later in totally different temperature. Also the salinity might be different. So now first thing we do is we think about which processes can actually change the temperature and which processes can change the salinity. And this is just shown in this TS diagram, and the arrows tell you the direction of the change. So any temperature change is either upward along the temperature axis or downward. Okay, and any change of the salinity is to the right or to the left in it. Okay, so for example, evaporation would increase the salinity, and any freshwater input would decrease the salinity. Cooling decreases the temperature, heating increases. It becomes a little bit more complex if you think about semi-enclosed system, because what can also change the heat content or the salt content is any inflow of some current. If there's a current coming into an area in adjacency, for example, it can change the heat content. Okay, but anyway, so it's good to know about the processes that can actually change temperature or salinity and how it looks like in a TS diagram. Okay, and then you can go out and do measurements in a shelf sea. Let's see how that looks like. Okay, for example, you can do that in Adelaide metropolitan waters. Here are observations. Okay, shown in different months of the year. It's not complete. Okay, this is Adelaide metropolitan water. Okay. Sort of ranging from Outer Harbour in the north, Barker Inlet in the north, to something like Seacliff in the south, maybe a little bit further to the south in some instances. Okay, and then showing these plots, allocating different colors to different. And one feature that you immediately learn is that yellow is not a good color to use. Never use color in Excel. Okay, and this is Excel, and there's yellow, you can hardly see it. Anyway, okay, you can see a seasonal cycle, and some months are missing, as I said before. But what do you see now here? Okay, you see how the temperature changes over the year. Okay, you can also learn about the timing. You can see that the temperature is maximum. So February, you can see all these red little dots are the temperature measurements, and the temperature varies. It depends on where you are, whether you are further to the north in shallow water regions, further to the south. You see some variations. Okay, but you can see 23 degrees, maximum maybe 25 degrees. Yeah, PM. Beautiful, okay, in February. And this is, you can use as a prediction. You can come back in 1 year and it will be very much the same. And you can see what's the coldest month of the year. You can see in August, you can see 12 degrees. What you also see that there is a salinity cycle. Salinity, okay, but there's a little bit happening here between August and February or so, but you can see that there's a big increase in salinity in May, here towards the month of May. Salinity is almost 1 unit higher. So there's a seasonal cycle that creates this. Okay, and you'll learn more about that when we talk about the South Australian Gulf Sea, you learn more about actually the processes that are associated with this. But in terms of understanding of the marine ecosystem, this cycle tells you all about the variations of ambient conditions. Maximum temperature, minimum temperature, the range, maximum salinity, minimum salinity. And you might even connect this with other features, like if you have nutrient information, there might be associated as seasonal cycles as well. All right.